tables with respect that these attribute 1 values are the same. I'm going to assume that attribute 1 is sort of the foreign key for those two relations, that those two values are going to be conjoined. So we see that, okay, for attribute 1 and attribute 1 are natural joins. So we have A, no corresponding value for A in my second set. So A does not become a part of my solution. B, okay, so let's search for the attribute 1 for B again. B is there in my second attribute, in my second relation, right? So B's attribute 2 R2 and B's attribute 3 R S2 become part of my relation. So for my natural join, the first entry that we have is B, R2 and S2, right? Because there is a common attribute value for both of those attributes. Then we have C. Okay, again, for C, we have a common value or a common attribute value for both of those. Okay, so attribute 2 gets R3, attribute 3 gets S3. So we have R3 and S3 for the value of C. Now we still have one more thing to do. We also need to check for D. D does not exist in either R or basically D does not exist for R. So that particular value of D is not part of the final natural join solution, right? So it is going to compare the attributes that are common across two tables. So that is attribute 1 and attribute 1. And then it is going to filter out only those results which have, as you guys say, that which have the relevant relations, right? And relevance in terms of natural join is basically these two attributes need to have a corresponding attribute here, right? So that is what we did. So remember the case for borrower.loan ID had to be equal to loan.loan ID, right, at some point. So that is what we said that was the relevant relations. Now, relevant relations might mean different things in case of joins, right? So a natural join just says both B and C or both, for all attributes, there has to be a corresponding attribute there. But there are other natural joins, right? So for example, we are talking about outer joins. So let's talk about the left outer join. So what does relevant relations mean in terms of left outer join? So a left outer join says that even, so we are going to focus on the left hand side of our table first. So again, attribute 1 and attribute 1 are the same, but we give more importance to the left hand side of our relation. So A, B and C are your A, B and C are your left hand side attribute values. These are always going to be present in your left outer join. So we have for B, we have a corresponding S2 and R2. For C, we have a corresponding R3, and for C here, we have an S3 again. That is fine. But for A, we do not have a corresponding value for attribute 3 in S, right? So that is why for B, we get R2 and S2. For C, we have R3 and S3. But for A, we have the value of R1. But since it's a left outer join, A needs to stay there. And since it's a left outer join and there is no corresponding attribute A for attribute 1, we have a null in case of attribute 3 here. Does that make sense? Any questions for left outer join? Okay, so the same thing applies for the right outer join, right? So the right outer join does the same thing as we did for left outer join, but now we're going to focus on the right hand side. See, the legs are on that side. So essentially the right hand side of our relation, right? So all values of S will always be present in our final relation. So B, C and D are there, but we just have a null because for D there is no corresponding relation in R. So for attribute 2, we have a null for the value of D, right? Then we have full outer join. So full outer join is basically the bow tie which has legs on both of those sides. So basically both of those relations get some importance, right? So for A and D, in case of natural join, both of those tuples are not included. In case of a left outer join, A is included. In case of a right outer join, D is included, right? And in case of a full outer join, both A and D are included with a value of null for attribute 3 for A and with a value of null for attribute 2 for D, right? So essentially a full outer join is going to combine all your results with respect to the common attributes that we have, that is the common column names that we have. And at any point in time, if we have any missing information, that missing information gets filled out with the values of null. Make sense?
Yeah, that makes sense.
So can we say, if that makes sense, let me ask someone. For example, let me tell you one thing. So this full outer join is a very powerful relation that is going to combine your relations, but not all database systems actually give you access to it. So for example, the database that we are going to use for this class is going to be MySQL, or mainly we are going to use MariaDB, that is a fork of MySQL, but essentially MySQL, but it does not give you access to this particular operation. So how can we compute a full outer join? So MySQL allows you a natural join, a left outer join, and a right outer join. Can we use one of these three or all of those three somehow to get a full outer join from this?
Can we do a union between the left outer join and the right outer join tables?
Exactly. And if we perform a union, will the B, C values be repeated? Just
So
a
No,
follow-up
they
because
won't.
there's
question.
no unique values, or
No, they
there's
won't,
no, yeah, there's only
because they
unique
are,
values.
yes, they are unique values, they are sets. Exactly, you guys are correct. So a union between a left outer join and a right outer join would end up giving us the full outer join, right? So even if it is not available to us, we can sort of jump through some hoops and get to a full outer join. And since these are computed on sets, the duplicated values are not going to be duplicated, right? Okay. Any questions so far? Okay. Now, one thing that we need to understand is when we are introducing a left outer join or a right outer join or a full outer join, we are also introducing our null value that is being represented or that is being inserted into your resultant relation. Up to now, all of the things that we have seen so far, none of those operations actually introduced a null value in your result relation, right? Everything was get that column, get that row, perform some operation on that row or column, and that was that. You never got a null value. A left, right, and a full outer join actually introduces null values in your final relation. So we need to understand how introducing null values can affect things in your database, right? So mainly, if you start introducing null values into your relations, everything needs to be handled or taken care of, and everything needs to be kept in mind in terms of those null values, right? So something might be null, and what does it mean? So as we talked about this earlier, so null basically means unknown or non-existent in a database, right? So this is not the same thing in terms of your programming languages. So for example, in your programming language, you can say that is null equals to null, or variable one, let's say that in a pointer in C++ or something like that. So variable one is initialized with a null value, variable two is initialized to a null value. Is variable one equals to variable two? Then a programming language would say yes. A database would just still say, I don't know. It's still non-specified, right? Null, is a null equals to null? For a database, it's not, right? Okay. So when we introduce certain null variables or null results, we need to understand how those null values operate in terms of different operations that we have seen so far. So mainly first, if we talk about arithmetic operations, um, every arithmetic operation that involves a null evaluates to null. So for example, for a summation operation, let's say we have the summation, let's say 5 plus 8, that gives you, I don't know, 13, plus 7, that gives you 20, plus null, that's null. right? So everything becomes null, right? So 5 plus 8 plus 7 plus null is null. That also applies to your other arithmetic operations as well. So that is how arithmetic operations take care of null values. Um, Comparison operations also involving null values evaluate to that unknown or that null value, right? So you can imagine that a comparison operation can, in a database at least, can return one of three things. Not a Boolean, that is one or zero or true or false. It can return a true, false, or an unknown or a null value. Right. So you can imagine that the unknown null value is like a third truth value in your Boolean expressions, right? Okay, yeah, null equals to null also evaluates to null or unknown. Yes. So let's see how Boolean operators and nulls behave, right? So if I say the AND operation, or basically if I say true and unknown, that is unknown. However, remember that for a false value, anything when we perform an AND operation with anything else always results in false. So a false and unknown would also result in false. You can imagine that an unknown can either be a true or a false in this case. And for both of those cases, it ends up being computed as a false. So false and unknown is a false. Similarly, for the OR operation, remember true or anything else is always going to be true. So that is why for null values, true or anything else is true. Other than that, everything else is still unknown or null. Right. So false or unknown, since it can either be a true or a false. So false or true might be true. False or false might be false. So we don't know what the result value is. So false or unknown is unknown, not unknown. So that is the inverse of that particular result of your operation. Again, unknown can either be true or false in this case. So not of true is false, not of false is true. So not unknown is again unknown, right? Any questions? No? Moving on. So that was your arithmetic operations and your Boolean operations as to how null affects those. Um, Now let's talk about other relational operations and how null is what is the behavior of null in those operations as well. So first, let's talk about the select operation. Remember, the select operation was the operation to filter out certain rows from a table dependent upon some predicate P. So if that particular predicate P evaluates to true, then those rows were printed out, right? So we talked about that example, for example, in the bank account that says, get me all the users with a bank balance of greater than $300 or more. Right. So that was your predicate, that is balance greater than equals to 300. And for those rows for which those are true, those values are